So for today's recitation, this is a fun subject. We want to give a tour of projects in the Fab Lab, not exhaustive, but illustrative. Most of these grew out, not all I think, but most grew out of projects in the Fab Academy and lived far beyond it. And we'll show what you'll be able to do once you learn all the skills we're covering. And so your guide is Danielle and Gracia, who's coordinated and will shepherd. Danielle?
Hi, everybody. I will start sharing my screen. So, welcome everybody to my flying journey in Fab Labs and drones. This introduction is a resume of my drones experimentations and their related projects during the last years. So everything started in FabAcademy in 2015, when I finally got the chance to get my hands on digital publication and give voice to my desire to experiment and to explore prototyping. You can consider me like a guy that makes things just following instincts and his hands, not really deeply knowing what he is doing. Just like the Variable Man of Philip Dick. Sometimes I woke up astonished at what I did, and I cannot believe that it was me. Also, I don't care about hiding like behind the studies that I've done in the past or the work that I'm doing now. I'm a dreamer, and my dream is to build things. So on the left side, you can see one of my earliest creations. It was like 16 years old there. I built a motorcycle from pieces from the scrapyard. And on the right side, you can see Laser Duo, an open source, dual source laser cutter machine. So during my Fab Academy, I started as soon as possible to make experimentation. You have to know that I was almost quitting Fab Academy at the beginning. And the reason was because I was not able to make my Fab SP working. So after this, I spent like 1 week staying inside the other room, try to understand what the problem was, and then understood that the problem was the flux. So the flux was creating short circuit. After this, I made a general purpose microcontroller board, which has the same chip of the Arduino board, that is called SashaKit. This board has the same specification of the Arduino, so therefore is fully compatible with the Arduino bootloader and libraries. The exception is that this board is entirely made in the Fab Lab. After 1 week, I published this open source board online. It was replicated by Jason Wang and FabAcadmFeb11, and because of this, I was extremely happy, and this pushed me further to make a lot of experimentations. So people might think that, you made a drone that is flying very smooth, but people maybe doesn't know what is behind the drone flying very well and having all these functionalities implemented. In this case, I want to tell you that I had a lot of failures. I was fighting a lot to make my final project working. So in order to achieve that, I combined a lot of different techniques. First of all, I started my research from the first day of FabAcademy. So guys, if you want to make your final project, start your research as soon as possible. I was carefully assessing all the steps before going on to the next ones. I was adopting a very tight time schedules. I was having backup plans like other 2 extra drones ready to fly in case I was crashing. I was testing myself in working in a reliable way under pressure. And then I was also learning when it's the case to stop when I was too much tired. Just look to the number of boards. These boards even blow it up during the flight of the drone. So at the end, my final project was successful. It was able to implement a lot of functionalities. For instance, the first one, the basic one, was a stable flight. Then was able also to carry on board a payload, which was a smartphone. This smartphone was running an artificial intelligence decision system programmed in Prolog and was transmitting real-time data to a server. And then at the end, it was also able to avoid obstacles using an autopilot system. So the core of this drone is a dual microcontroller board with one microcontroller managing the flight and the other microcontroller managing the sensors and the communication through the phone. In this case, the autopilot was implemented on the second microcontroller and was able to constantly analyze the radio channel received from the transmitter of the human control. And then it was interpolating this with the specific automatic values in case an obstacle was detected, for instance, like a wall, a person, and so on. And this happened some years before commercial drones started to have obstacle avoidance systems implemented in the market. So we can actually see a small video where the drone is flying with a couple of water on top of it, and this was to test the stability of the drone. Then you can see the performance of the drone. The drone was very active and flying very fast in a very precise way. You can also see then that it was calling the smartphone. The smartphone was sending data over internet to a WebSocket server. And then now you can also see the sonar sensors being attached to the drone. So this is a crash that made me lose like 1 week of time. This just before the final presentation. And this is actually the drone avoiding the obstacle successfully. Okay, I think we can go on. So after this, I decided to quit my limited job as researcher in Italy to jump to FabAcadmFeb11 to teach FabAcademy. And I also, therefore, continue to develop a lot of different drones. In this case, I was changing like their geometry, the sides. I was adapting them to different scenarios for different payloads, supporting GPS, for safety requirements, and so on. So also, the first implementation of the file controller became a final approach, a full project on its own. In this case, the project is focusing on developing general purpose open source fabbed electronics, the SashaKit boards. In this case, you can find SashaKits for a lot of different implementations, hosting different microcontrollers with different architecture, but also implementing other functionalities like a stepper driver or USB to serial converter, which is way cheaper than FTDI cable. So guys, try to make your own FTDI converter. They are also being produced in China and used as machine controller for my laser cutter machine. And they have been replicated 100 times in fab labs worldwide. And following like a super nice open source cycle, everything that was given to the community was coming back to me with a lot of modifications. And this modification addressed purposes that I was not even thinking of myself. SashaKit has also been used in 2 bachelor theses of my former students as prototyping platform from the University of Rheinland, University of Applied Sciences of Rheinland. Okay, then due to the complexity of my final project and the personal desire to help others understand how to make drones in the Fab Lab, I started simplifying my drone to make it easier and cheaper to be built. These changes included a simpler file controller, cheaper parts, and less components involved. The outcome of this is a newer version of the drone, called SashaCopter. This drone is especially designed to be fabricated and built in a workshop. The open source repository is online and contains a 70-page step-by-step manual how to build the drone, a bill of material, and all the required design files to reproduce the drone itself. After this workshop that I first offered in Fab12 in China, I got many requests to replicate this drone worldwide. The workshop have been offered to a wide range of publics, from like people with no backgrounds to Fab Academy students, from elder to kids, from institutions to companies, from like very short workshop to 2 hours till like 3 days of duration. Some examples are kids building an octocopter, a workshop held in Airbus, elder people making SashaCopter. So this also made me flying around a lot. So it's a small drone, but made me flying really far away, you know. And sometime I even went to a place and I found that somebody else had replicated my drone for some purpose. A special example of this is a student from the Helmut Schmidt University in Hamburg, which have replicated my drone for a university project. In this picture, you can see the drone flying at the MIT in Barcelona, Maker Faire, inspecting a coal mine, and so on. I did a successful cooperation also with Aldo Sollazzo in Romania from Barcelona. The objective of this cooperation was to make a safe-to-be-operated data collection drone. And in this case, I further improved the electronics of the drone, adding a more powerful microcontroller on board. So this new file controller was able to record the flight, like the movements that the drone is doing, and then was able to reproduce approximately this flight when needed. The guys from Barcelona designed this beautiful cage around the drone, which is made out of carbon fiber rods and polypropylene laser cut protectors. And this drone has been proved to be really successful also in moving on surfaces, for example, rolling on the floor or on the roof or on the wall. So here you can see a video. The drone is very reactive, even though it has the cage on board. It can easily bounce towards walls without any damage, okay? And then you can even drop the drone off from a certain height, like this. And of course, you can make it roll on the floor. So this opens up for more experimentation about automatic controlling of the drone. Okay, so here you can see some of the future developments that I would like to integrate. So I would like to have more sensor on board, so have more powerful microcontroller with maybe an operating system. But this is like something paused at this time because I'm focusing much more in building machines. One long-term dream will be to replicate a complete Fab Lab from scratch. So we will do this later on. So guys, when you fly with the drones, you have to try to be as safe as possible. So drones can be very dangerous in many different ways, especially if they will hit somebody with their weight or even with the propellers. So guys, if the propellers are hitting somebody, they will rotate so fast and they have so high torque that this can be extremely dangerous. Furthermore, guys, you are developing an experimental drone. So this means that you have to take care that all the connections are fine, that the frame is solid and everything is very well attached. I highly recommend you to follow these guidelines step by step and to do the first tests without the propeller. Remember, guys, one mistake in this case can be really dangerous. So guys, I would advise you to enjoy your Fab Academy, because if I could, I would enroll again under a fake name, okay? And this is why the reason why I love teaching it. I can see similar dreams being replicated in the eyes of my students, while I can continue experimenting things, of course, on my own. Also, between me, my colleagues, and the students, Fab Academy has created an incredible friendship that strongly persists over time, and that makes me comfortable whenever I am in the world. So I would like to thank you for listening, and also to thank you very much the current the FabLab Open Docs, FabLab Camp Import, and FabLab UAE for supporting me everywhere. So if you like, I can do a small flight test. Like
so 2 notes. Yeah. So first, just a note. You maybe feel like there's a gap between all of you and Danielle, and I think it's great the way he introduced it to explain he didn't start knowing how to do all of this. In fact, he started knowing how to do none of this and just grew into it. So please do a demo.
So guys, just maybe a quick thing. First, start always the transmitter and then after the drone, because if there is noise, the drone can start flying and doing weird things alone, okay? So first I will start the remote controller. So secondly, the drone has a special activation system. So in this case, the drone is completely deactivated, doesn't do anything. You have to arm the drone. This is like on-off switch, okay? Before you do this, make sure that nobody is in the room. The room is clean and you could not damage anything. Okay, I think that was it. Thank you very much.
Okay. And then just one last note. If you're interested in building drones, part of the point of this is you don't have to and you shouldn't start from scratch. You can stand on Danielle's shoulders and build on what he's done and then extend it.
Thank you very much.
Okay, nice. Thank you, Danielle.
Joris, I think it's your turn.
All right. Yep, thank you very much. Actually, it's really funny, Neil, that you said build on Daniel's shoulders, because my talk is kind of about that. My name is Joris. I did Fab Academy in 2017 in Amsterdam. And today I'm going to talk to you guys about how I actually am currently making a living off of my final project that I did in Fab Academy, but it's in a little bit of an unexpected way. I'm going to talk a little bit about the failures that I encountered after Fab Academy, but also how I sort of managed to turn that into something really positive. So let me just share my screen with you all so you see the things that I've been working on. I hope you're all seeing it. So this was my final project, and what this was Iot Lego. So basically what you're seeing here are different bricks that have different functionalities to create a really simple IoT system. So the base module had a Wi-Fi, ESP-based Wi-Fi module. Then the red thing is a temperature and humidity sensor, and the top layer is just an LED visualization layer. And so what that allows you to do is put together these different components and build your own system without any soldering or knowledge of technology, really. So the whole vision behind it was that everyone should be able to experiment with IoT and do that in a fun and accessible way, and that's why it was made compatible with Lego. So for my final project, I developed a series of these modules, each doing different things, and they were laser cut. Basically, the enclosure was laser cut acrylic, and then I had my own PCBs, and the top was 3D printed. Now, before I go on to saying how I built a business out of this, just a little thing that I figured out after Fab Academy that might be useful for you now. This was the next iteration after Fab Academy where I made a professional PCB. So the way it works is this is a sensor PCB, and it has an accelerometer, a gyroscope, a light sensor, etc. And then it has the pogo pins that help it connect to the other layers of the bricks. And then the shape of the PCB is so that it fits in a laser cut enclosure. So this is kind of what the internals look like in a later version. What I did was during Fab Academy, I used to always 3D print the top part, the Lego studs. And what's really hard with Lego, I completely shot myself in the foot by making something that's Lego compatible, because I thought it's sort of a universal design and it's the easiest thing in the world because the dimensions are set, they're already there. But what I kind of failed to realize was that Lego is one of the best engineered products in the world. And so to get proper compatibility in terms of clutch between something that you make in a Fab Lab and actual Lego is incredibly hard. So I struggled so much with getting actual Lego to fit on my IoT blocks. One of the ways I overcame that was I started milling the acrylic top part. So rather than 3D printing it, I took the same sheet of acrylic I used for the laser cutting, and just on the CNC, I milled out the Lego studs. And I don't know if you can see it. There's the green one in the picture, and then the clear one, I chamfered the top of the studs a little bit so that it clutched really well. All I want to say is if you're doing a final project or any project that involves any sort of Lego compatibility, talk to me, because I know everything about how to make Fab Lab Lego. Like, literally, I've tried everything. So please don't be a stranger and talk to me if you want to know about Lego. These are some other pics of how the next version worked after the Fab Lab. What happened was, I don't know if you guys are familiar with this, but this is the M5 stack. And the M5 stack is a product from some talented guys over in Shenzhen. And I have one here. And essentially what it does, it's an IoT prototyping kit. And it's modular. And you have all these different modules that you can stack on top of each other to create your own IoT system. Now, that sounds really familiar because that's essentially what I was trying to create. And what happened was I'm going to try and visualize it. So I put a lot of time and energy into trying to professionally manufacture the thing that I had done for my final project. But besides manufacturing is hard, so I just struggled there. But the other thing I struggled with was I didn't really have a clear application for my final project. Of course, you have the Applications and Implications Week in Fab Academy, but I think Fab is really great for making you deeply understand how to build almost anything and giving you that superpower in life. But it's equal if you want to, commercialize it or turn it into a business or take it further. It's really important that you have a good application for it, like Daniele with his drones. When that's being used for mapping terrains, etc. There's a really good application for that, and then projects, when they have that good application, can really thrive and expand across the world because people can use it for something. And I just didn't have that. My product was fun, and the prototypes worked well, and people were excited, but it wasn't really useful. And so what I did more recently is, and I did my thesis on this in London, is I started to build the ID challenge kit. And I made curriculum around the idea of using technologically advanced Lego as an innovation tool to help people develop new ideas for products and services from a sort of human-centered approach. So I took some things from design thinking, I took some things from other design methodologies, and I started putting together a kind of a game using IoT enhanced Lego, regular Lego, and then some design principles like designing for a persona or designing for a challenge. And so what I ended up with is I stopped developing my point because I figured out I'm not an engineer by trade, and designing and building something in a fab lab is so radically different from designing and making something for manufacturing at scale. It's a different skill in a lot of ways, and that just wasn't my interest. My interest was enabling others to do something cool and useful. So what I started doing is I just started running workshops with my Idea Challenge Kit and actually just third-party hardware. What I did was I got a bunch of seed products, I got some M5 Stack products, and I just started finding the application for the field I was working in with third-party products that worked really solidly, so I could run these huge workshops. And here's a little example of a workshop we ran about how to improve police stations. And one of the participants came up with the idea, this was one of the bricks that lights up. What if victims of a crime can come into a police station and change the light according to what happened to them to calm their mood? And those are sort of really empathetic ways of rethinking something like a police station, and the IoT Lego and the real Lego helps people materialize those ideas. So what I do now is I run these workshops with large companies like Heineken, Procter & Gamble, a lot of government institutions, and I live off of those workshops. And actually what I'm doing now is, rather than developing the whole thing from scratch, I'm taking everything that I know from Fab Academy on how to make Lego connected and what it would take for this to work really well for my application, and I'm just modifying third-party platforms. So at the moment for the M5 Stack, I'm designing my own bottom PCB. So this is their standard PCB, and I'm just creating a system that works beautifully with Lego, and I'm making my own little Lego compatible PCBs for LEDs and motors and things like that. But the thing that killed me was the actual microcontroller and the wireless communication and the antenna design. That whole thing, it really almost killed me in the end, because I was just spending so much time on it, and that's not ultimately what my product does, because my product just helps other people materialize their ideas. And so when I figured out that, I learned how to build everything from scratch during Fab Academy, so I know exactly what it needs to do. But now I also know what it doesn't need to do for my application. And so just modifying or building on the shoulders of someone else's work can be a really powerful way to advance your project if you know what your application is. So that's what I do currently. I run these big innovation workshops with Lego and IoT, and I live off of it. So I live off of my final project. But not in the way that I had envisioned it. I envisioned it to be a product that I would mass manufacture and just sell as hardware. And now I'm selling almost like a consultancy service based on that. So you never know where this is going to take you. But thinking about your application and taking your time to figure out how your invention can benefit others, it can be a really powerful thing. That's it. Now I need to figure out how to stop sharing my screen.
Danielle, are you there? We need to watch time.
Yes. Carsten?
Okay. Keep everybody to the 10 minutes to stay on schedule.
Yeah. Okay. Carsten or Zin, are you connected? I think you can start.
Yes. We are ready to present. Okay. So, thanks for the chance to present some of our work. So this is not an outcome of Fab Academy, but this is an outcome of whatever we have learned in the Fab Lab and whatever you can do in the Fab Lab. And this is about make something big. One of the assignments that really impressed me during Fab Academy. So it's about Fab House, a project that we've created here in Camp Lindford, The people behind the project are Aisin. She's with us and she will talk in a few minutes. Daniela, you know already, and me, I'm a professor at this university, which is located in Germany, so somewhere in the center, and that's our wonderful campus. We are a Fab Lab like any other Fab Lab. Maybe we are a little bigger and have a well-equipped facility here. But what drives us is teaching and making people aware of what they can do with digital fabrication tools and even manual tools. So we have different target audiences that we want to address, which is pupils at school. We do a lot of workshops and symposiums. There's someone, okay. And then citizens, like we invite people to come and to use and to make use of the Fab Lab and share whatever they want to share with us, and even to create projects together. We have the economy, which we want to support in terms of research and competence. And of course, we have students, and this is our main target audience. We do a lot of teaching in the Fab Lab, and we have accredited courses already, similar to or in alignment with Fab Academy, which take place every semester at our university. We do a lot of global work, which is Fab Academy, FabAcademy Bootcamp, and so forth. Neil, yeah, inspired by your quote of how to make almost anything, which is, I think, like a golden rule for all of us. I've been to Fab 10 conference in 2014 and was inspired by a wonderful talk from Alistair Parvin about the WikiHouse concept. And it took me about 3 years to make this a project at our university, because students had to get attracted by the idea and really wanted to do this. So the idea was born, and in 2017 we kind of pitched an idea to the students and they applied for it. And the idea was to make a WikiHouse. We call it a Fab House because it has a different concept in mind. The concept was we wanted to make something sustainable, a project, a house where you can live in, that is sustainable in terms of materials that you use, but also in some other aspects, which Isin will talk about. What does sustainability mean? It means minimize the resource consumptions of whatever you use, create the greatest possible benefit for the customer/user. We have heard about the persona or human-centered way of creation of things. And of course, focusing on the ecological environment. So luckily, and you see Isin here in the picture as well, we got 12 students with different backgrounds, and that's, I think, something interesting to tell. None of the students has had any prior experience with the Fab Lab or any fabrication skills. The students were from computer science, environmental sciences, mobility and logistics, and international business sciences. And they all came together for this project to make something and to create something. Following a methodological approach, we call it the Eco Design Sprint, which has been presented at Fab 14 in Toulouse. You can find the paper and read it if you like. It's an iterative approach of how to make solutions which are sustainable and which address the user needs. Aisin.
Hi. Carsten mentioned about the theoretical aspects, so I'm going to talk about a little bit of the process. So we started with the WikiHouse idea. WikiHouse idea was about the open source, how an open source structure can be printable via CNC machine and we can build it. But the WikiHouse has limited sustainable solutions, so we wanted to move forward with the more sufficient, self-sufficient housing system, how we can implement the open source house system with the self-sufficient house system. So we will look forward after WikiHouse to Earthship project, which belonged to Mike Reynolds' project. It contains many disciplines at the same time. They use recycled materials, wind, electricity, and solar panels, and so on. And after that, we have to look for the comfort conditions, how it should be the house, the form of the house, the material of the house, and we came up with the idea of that was a leaf in front of my house. It was a converted leaf, and it was collecting rainwater in the core. So I came with the idea of how we can actually this idea how we can implement in the house. So it came idea of the core of the house also can grow from the middle with like a Lego parts exactly with the open sources, and you can embed all the building system on the core, and there's a water supply or energy supply, and you can add a room, or you can extract a room, and you can use this core system by unprofessional people who want to change something in the house. Is an open source, of course. And then, this is the graphic of it. Can be triangle core or hexagonal core or rectangular core, and this is like as a sustainable approach. It can grow or shrink, whatever you want. What's your need also from what's your expectation of the house, and do you move forward, Karsten?
Yes, I will. So just to put emphasis on this, the idea of sustainability for us is not only on the material that you use, but also on the use of the house itself. So this modular system enables you to grow, to let the house grow and shrink. So imagine that you're a couple and you don't have kids, you need a small space to live. Then you got your kids, you have to expand, you have to grow the house. And later on, when you're almost retired, you want to shrink the house again because you don't want to spend too much time on cleaning the house and stuff like this. But what we did also was testing, of course. So we wanted to identify the potentials for sustainability, which is, for example, here the insulation material. So we did some tests with different kinds of material, of course, ecological friendly, but also efficient in the way we use it. We did experiments with almost every part of the house, like here, for example, the roof. We did paper clay tiles, as you can see on the very top of the screen. We tested them. We did tests with different connection types because we didn't want to use screws where not needed. And we did a test with different materials. Like at the end, we came up with metal sheets as roof material, for example. We did tests on water supply and filtering in order to make use of the water that we collect. We also did some base testing on biomass reactor versus solar heating in terms of heating system for the house. And of course, we made prototypes, small-scale models of the house, as you can see here in the back. So there's the model of the house, and it is it was to test the connections, the joints, and all this details. And then we made a real-scale prototype to see whether the parts fit together, whether the system is assemblable at all, how difficult it is for the user to make it, because as Ethan said, it should be we should be able to be made by anyone who has no technical skills. Yeah, we did start the fabrication and production, I would say. Had a lot of smaller parts that we then assembled.
And we start with the construction, the fundamentals, and the joints, and then walls, the house, and we used isolation for the fundamentals, and we use different isolation for the walls, which is wood wool, and all of them for totally sustainable, all the materials. It's for isolation.
Time check. We're doing 10 minutes a person.
1 minute, guys.
4 minutes over. So.
Yeah, this is like this is the process actually, Karsten. You can pass through. Yeah, this is
1 minute left.
Covered up the house. Yeah.
Let me just then quickly. So we wanted to prove the sustainability of the house and the life conditions. So it is not just a prototype. It's real. It's a real house, even though it's small. But this is just because of legal constraints. We were not allowed to build it in a bigger scale. But we tested it. It's still existing. It's standing outside, and we tested the material and also the architecture of it. So we wanted to build a real house. We did a real house. We tested its sustainability in multiple ways, and we can prove it. We learn how to improve, and we will create a new version of the house very soon. And of course, our approach has been tested. All the projects, so the documentation is online. You can find it at our web page. It includes a manual. It includes a video tutorial of how to build it and how to create it. And of course, the files that are needed. And as a forecast, in 2020, we will have the Landesgartenschau here at Kamp Lintfort, which is a huge fair, a national fair. And two things will happen. The first one is we will build a second Fab Lab here in Kamp Lintfort, which is the Green Fab Lab. So it is a Fab Lab made for let's say green purposes. And the second one is we want to build another house, which is then of course open source, but in a bigger scale as right now. That's it.
Thank you very much. Okay, guys, it's the turn of Roberto. Roberto,
Hello.
are you connected?
Hello, how are you? I'm sharing now the screen.
Please start sharing the screen. You have 10 minutes till now.
Can you see my screen now?
Yes.
Yeah. So, hi everyone. Hi Fabbers. I'm Roberto Gallo. I'm from Ecuador. I'm an industrial designer. I've been involved in arts and science. I've been 4 years in this network. It's amazing. I'm following each program that network brings you. BioAcademy, FabAcademy, and now Grow with Fab is this incubator program. So what I've been doing, I've been working in Latin America and also in Ecuador, in my country. So in Latin America, I did this Fab Pavilion that we present in Chile. You might know me about this project. And also in Ecuador, we've been pushing and helping Fab Lab Yache, and it's public, and it was a little political for me. So I decided to make my own lab. It's a company that we hacked as a cooperative. It's a really nice place, and we are really happy to manage it. This is the view of our new space. It's like in the center of Quito, and this like Central Park. And also, what I'm doing now is improving bits and atoms bin. That is my final project. What moves me, my motor is frustrations. When I get frustrated, I started to be creative and propose ideas and solutions. So I got some frustration in my career, and one was about drawing, 3D drawing. I'm left-handed, and it was really difficult for me to use CAD and keyboard and mouse with right hand. So I decided to make a solution and propose this pen that allows you to make 3D vectors, and that gives you 3D modeling. No, the spiral development is one of the main tools of the Fab Lab. It was really crazy how FabAcademy is so fast. I spent 11 weeks doing things that wasn't working. So I was like trying to recap everything, and I found this spiral development tool that Neil is talking about every class. And in a week, I solved the main point of my project, that was managing data in order to have these 3D vectors between the accelerometer and a computer. When I did that took me 1 week, and then I got 3 weeks more to improve and to put it working. It was a really successful project. It was in the top 10 of projects of 2017. Then I took Bioacademy, and it changed a little bit with bacteria growing inside and making ink, and you can, like mix this ink in order to have all the colors that you want. In 2017, the state of my project wasn't really good. I was really frustrated again because I got a user, the computer, and CNC. So I connected the bits and atoms with a computer to a CNC in order to move and generate these drawings with the CNC. And it was not real time, and it was really difficult to use. I had a lot of problems as the Lego project, Then I started Grow with Fab in 2018, and I get another problem. I was using a smart device in order to make it better and more friendly, but it wasn't. It was about compatibility. It was a lot of problems around it. And one of the best things that this year gave me was this research. I've been researching, and I have a lot of acceptance of my project with the creative user. So now, in this year, the project is working just perfectly as I wanted. I will make a demo of it. Now it has this real time, and the main thing is that the user will be able to control a cursor of the computer. Whatever operative system that you have is okay, and whatever machine that you have is always okay. So you will be able to control the cursor of mouse and also directly with the CNC. We're planning to launch this project at the Fab conference. We need a lot your support to do this in a well way. Some conclusions for you students. Spiral development is the best tool. It's not about 3D printing and that stuff. It's about how you manage your projects. Finding the first spiral is crucial for your project. You have time now, so you can see exactly how to find this starting spiral. And also, I think that machines need to be adapted to people, not people to machines. So I don't like, to be using a mouse and a keyboard and a screen and everything. I love to use like a normal tool, more natural. So I will present let me see. This is the video of the pen working. I have here the prototype. It is quite difficult to get the same times as you are taking data and sending to machine in order to have this feed rate that is moving, the pen here, the marker. So, but it was really nice. It's really, really nice and also I prepare here. You have, as you can see here, this is the data that is giving me the bits and arrows pen. We have to wait a little bit. Now, as you can see, the data is changing, and also the cursor of my mouse is also moving. So I can control the cursor, and also I bring data to the machine in order to move also the machine. So this new feature that we are now working on is a switch, a digital switch that allows you to control the computer, and no matters which program are you using, and also the machine, directly with G-code. So that's my project. We are really happy to develop this, and now in this lab, everyone is really happy. It's a really nice lab. So that's all. Thank you so much.
Thank you, Roberto. Francois, are you connected? I think you can start.
Meta will start before me.
Okay, hello. First, thank you for this opportunity for presenting our project. Our project is not so technical, but it doesn't mean that we don't need great technicians and engineers to join us. So first, I would like to tell you a few things about the Rogue Lab. You see it on the picture. It's a small fab lab, the first fab lab in Slovenia that was established in 2012. It's part of Museum and Galleries of the city of Ljubljana, and it's also financed by the municipality of Ljubljana and European Commission. So we have all the regular Fab Lab programs, but in addition, we have also regular call for artists and for designers to develop different projects tackling different societal challenges and problems that we are facing today. In the previous years, we were dealing with projects such as disability, and this year we will start tomorrow. We will publish a call for designers about active aging. Well, why about active aging? Because we find that, in fact, the population in Europe and in the world is really aging quite fast, and we need to find some design solutions to different problems that those users are facing. We think that the environment of Fab Labs is the most suitable environment to approach this kind of problems, because we are connecting professionals, professional designers, engineers, different users, but also do-it-yourself masters. And we are connecting those people with the help of different technologies. That means that the response to those kind of problems, which are complex, can be better in this kind of environments, as we thought. Well, this year we are launching the project for the first time in the way to connect different Fab Labs around the world within the project. That means that one part of the project, the first part of the prototyping phase, will take place in the towns where the designers live, and we are searching for different labs, maker labs, fab labs, and other facilitators to join us and to help the chosen designers to develop the first part of the prototype in their local environment. In fact, what we will do tomorrow, we will launch this. This is already the call that we have launched for the different labs. And in fact, when we choose the designers, this will be on the 22nd of April. We will try to match those designers with partner labs around the world. And after this first phase of matching, the first iterations of ideas will be made in local labs. Together with the partner labs, we will also choose the mentors for different projects. And this first phase the second phase, but the first phase of iterations will take place until the 22nd of June. After that, the designers, the chosen designers, and the supporting technicians or mentors will join us in Ljubljana, where we will organize an international collaborative prototyping workshop. At the end of it, we will produce 8 prototypes that will be, in fact, exhibited in October in Ljubljana. So, in fact, in this moment, yes, we are searching for partner labs, and we are searching for designers to join the project. So maybe François, do you need to add something?
I just can tell you what for now who already joined us as a FabLab partner. We already have 8 FabLab from all over the world. We have Makerspace, Volume Co-working from France, from FabLab from Quebec, from Portugal, from Northern Ireland, Paraguay, Italy, and from Philippines. So think about joining us as well. As you understood, there is only the technical part from the first phase of the prototyping for this for the partner Fab Labs to support. All the rest, all which will benefits to the participant, which is individual coaching support, mentoring support. This will be done from our Fab Lab, from Rogue Lab online, as well as some design thinking courses. And you will get also as a partner Fab Lab the possibility to come to the workshop in Ljubljana with the participants you support, and all the travel cost and hotel costs are supported by Rogue Lab. So if you have any question about this, we'll be happy to answer.
I think we can go to the Q&A session if everybody has questions about the projects.
Good. So questions or comments on anything?
Yeah.
François, please stop sharing
Sorry?
Was there a question?
the screen.
Stop sharing the screen. Okay, I couldn't hear. Sorry.
And mute, thank you.
Danielle, what's your next project?
My machine. I think I will pause the project. But mechanical.
Sorry, Danielle, we're getting a bad dropout from you.
Parts. So it's something like similar to what Jens did. Well, let's say like the linear. Is it way more than that?
Danielle, we had dropouts, so we only got about half of that, unfortunately. But to relate this to coming recitations, we're going to have one recitation just on machine building. And then another recitation is going to be about programs over the FabLab network. Questions or comments for anybody? And or projects to share?
I think there is in the chat.
Hello, can you hear me?
Yep.
Yeah, I have a question for Joris. Is he still in the...
Sure, please ask away.
Yeah, so basically what he tried to do was integrate Legos and electronics. So I'm interested in toy design myself. So I would like to know, will there be any copyright issues when we're trying to modify those, the pieces of Legos?
Right. So I had a little bit of dropout. Am I correct in thinking you said, are there any copyright issues with the design of Lego if you're modifying that? Was that your question?
Yes.
Okay. So yes and no. So Lego does not have a utility patent anymore on the stud and brick system. They have a lot of other things. They have intellectual property. I'm not sure maybe you haven't had that week yet. There's a difference between utility design patents, and intellectual property. For example, one of the things they're really strict about is using the minifigures. So actually using the minifigures in any kind of promotional material is a big no-no, as well as using the brand name Lego. But the design itself is as good as open source. What you see a lot of other companies and startups do is maybe they'll modify it a little bit. What I did was I made the bottom piece a different kind of grid. So this is just slightly different from how Lego works. So I would definitely just advise to slightly modify to be in the clear, because I haven't done the full legal due diligence. But if you just make the holes a little bit different or just a little different shape or size, you're definitely in the clear.
Thank you.
And let's see, there's a question in the chat about aging, about the focus and RogLab.
Yes. In fact, yeah, the focus will be, we will open different topics like loneliness, losing of motor and sensorial skills, poverty, etc. Then there are also certain topics that different elderly person communicated to us. So we have also five concrete challenges, and there will be also one open challenge where the designers can decide and identify their own challenge together with an elderly person and solve this challenge. So plenty, it's quite open call, so different types of people driven by different types of stimuli can join us, in fact.
So it just occurred to me, if you put all these projects together, you would end up with Comp Lindfort building a house instrumented by Eurus with an interface from Roberto with logistics through Danielle, or active aging by Francois.
Yeah, this is a great idea. Why don't you propose it? Just answer to the call. Okay.
Okay.
Maybe the Bixen Aaron Spain, the future could draw a drone line in order to follow that line.
Yeah, I mean, I take coordinates for the input of the autopilot, so you can try. Yeah, with some testing beforehand.
So once again, this wasn't meant to be exhaustive, it was meant to be illustrative. It was showing some projects that grew out of Fab Academy and some people and the careers. And once again, don't be overwhelmed, because they all started as you and then just through these stages grew into everything you saw here. So that was a great tour through both projects, and more than I expected, I appreciated hearing each of your life arcs.
Thanks.
Great. Okay. Thank you, Danielle, for organizing. Thank you, everybody, for presenting, and I'll see you in class where we'll make our first little step in electronics.
Thank you very much.
Okay.
Bye-bye.
Bye-bye.
Bye.
Bye-bye.
Yeah.
Recording has stopped.